All right, let's finish the last page of this. We have another molecule in the middle with 3 different reactions coming off of it, and the first thing that we have to do is name it. We can see we have a functional group on this one. We have the alcohol functional group. So we're looking for the longest carbon chain that includes this carbon holding the alcohol. So one option would be right there. That's a 1, 2, 3, 4, 5, 6 carbon chain. And another possibility would be right there, which is 1, 2, 3, 4, 5. It's also a 6 carbon chain. When there's a tie like that, you can just pick either one. The name's going to be the same either way. So we're going to go with that right there. So this is going to be a parent chain with a hex in it, and it looks like all of our options have that, so we can't rule anything out yet. Now we want to number that parent chain starting on the end closest to the OH. So we're going to number from right to left. The alcohol is on carbon number 2, which means that this molecule is going to be a 2-hexanol. And it looks like we still can't rule anything out because these are all 2-hexanols. So now we want to look at our substituents. We have 2 substituents. One is on carbon number 3 and one is on carbon number 4. The substituent on carbon number 3 is called methyl. The substituent on carbon number 4 is called ethyl. And let's take a look at our choices here. This one has a 3-methyl-4-ethyl, 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 3-methyl-4-ethane. Ooh, so we can cross one of them out. So it looks like what we have to do now here is just know between A, B, and C, which is the correct way to put the name together. Remember, when you're naming, the first part of the name is the substituents. So C is wrong because C has the substituents at the end of the name. So we cross that off. So now we're down to A and B. And these two are almost exactly the same. When you're naming your substituents, remember, you're going to put them in alphabetical order, not in number order. So ethyl will come first in the correct name for the molecule, even though it is a higher number. So the correct answer is A. Now let's move on to the reactions. The first reaction, number 17, looks like we're going to do an oxidation reaction. For this reaction, we want to start by, let's just start by redrawing the molecule exactly the way that it is. In this oxidation reaction, we convert a carbon-oxygen single bond to a carbon-oxygen double bond and remove the hydrogen from the OH. So there's that product. Questions 18 and 19 are a dehydration reaction. So again, we're going to start by drawing the molecule exactly the way that it is. In the dehydration reaction, we remove the OH and we remove a hydrogen from one of the carbons that is adjacent to the OH. So we'll remove this hydrogen, and remember, we remove the OH. And in between those 2 carbons that we just worked on, we're going to make a double bond. I'm going to take those hydrogens off just to make it easier to look at and see the double bond. So that's one product. Now it looks even better. Now it says let's draw a different product. So let's start again by redrawing the whole molecule. Now the product that we made in 18, we made that by taking hydrogens off of this carbon atom. We also have a carbon atom over here that has a hydrogen on it. So we could have taken that hydrogen, take that hydrogen, take the OH off, put a double bond in between those 2 carbon atoms that we just worked on. So there's our other product. And I'm going to clean that up, make it look better. Like that. And then last question, what is one of the medical applications of ether molecules? Can they be used in birth control pills? No, remember, that needs to have that 4 fused rings with an alkyne. Can they be used to treat methanol poisoning? No, that's ethanol, not an ether. General anesthetic, yes. Remember, in the 1800s, that was the first type of general anesthesia.